皆さん、こんにちは。どうぞよろしくお願いします。私はフイです。I'm RISC-V ambassador from RISC-V Foundation and senior software engineer from in platform enablement team from Red Hat. Great sense to allow me to make a presentation about Linux distribution on RISC-V. So in this half hour, I will make a brief introduction of Linux distribution and the software component status on RISC-V. So let me start with some background information. Since 2016, Red Hat engineer and some Fedora community engineers start working on Fedora for RISC-V. Then they have they working on that pretty good. And then in 2018, Fedora can running on RISC-V hardware, and also with the very great graphic desktop support like Gnode. So and now Fedora 33 is running on several hardware platforms and QEMU with graphics desktop, and more hardware will be supported next year. So you can see in the picture we support D1 Starlight development board, so-called Vision-V next generation, and also we also support Icicle and Sci-Fi platform. And we are working on this Fedora Remix, but in the few months later, I guess we can try to make a Fedora official release for that as a secondary arch. But our primary target is promoted as a Fedora primary arch. So you can see the status of Fedora on RISC-V is pretty good. We are making the bootable imaging, which boot from OpenSBI to uboot to grab, and at the end we boot the Fedora imaging. So it's a standard boot flow. We also make several repository in China. You can see these two main repository from Chinese Academy of Science, and also from we also have some repo from Starfi and some other place. So we are expanding our package and trying to cooperate with Fedora RISC-V Rocks, which is the first Koji system in the world for RISC-V. So we are accelerate our development, and we can have a better support in the future. So we are using the Koji system for building the RPM package and imaging. For now, we are not just using QEMU as a builder. We're also using some hardware. We're planning to making some RISC-V server next year, which can build package and imaging faster. And so we have several, as you may know, we have several Koji systems in China, and also we have a Koji system in US. But Koji system is just one of that. We're also building a OEPKG build system for RPM package and imaging. OEPKG build system is supported by Chinese Academy of Science. They include Koji system and at Jenkins and some other interface, web interface. So they make packager more easier to pack the software and imaging. Once they finish the configuration of OEPKG, they can just make a single push, and then the package will come out. So it's much easier for developer. So let's the build system for RISC-V, Fedora on RISC-V, and now we have supposed several different hardware platform. We are trying to maintain the hardware platform from Starfire, which is called Jinhong platform JH7100. The next platform will come out called JH7110. We are working with them and make the imaging can support more platform from Starfire. This platform will be sold very soon. So we are looking forward to can buy that on the market. So this is the desktop showing from Starfire Starlight system. As you can see, we also enable Firefox on the platform. So the software ecosystem support is much better and it's usable right now. We also support OWinner D1. The OWinner D1 is the core of OWinner D1 come from T-Hat, and this platform is very first massive product platform, and you can buy very easily to get it ordered online. And we are maintaining some imaging for this platform. Also trying to upstream uboot, kernel, and OpenSBI for this platform. Since I also have this development board called Icicle from Microsemi, so we are working on making sort out all the package and making Fedora imaging on that. So we are already running Fedora on that. Just need some time to make the official imaging. And as you may see, for now, the most powerful platform for RISC-V is Hi-Fi Unmatched platform. So you can plug in a graphic card on the development board, so you can have a better graphic desktop experience on that. And we also we already run Fedora imaging on it. Not just Fedora can running on RISC-V platform. For now, several other Linux distribution can running on that, like Arch Linux. Arch Linux can using OpenSBI uboot and OpenSBI and uboot running on some hardware and software platform. And Debian is a very first desktop distro can running on RISC-V. Recently, we also get Gen 2 community engineer also make Gen 2 can running on the hardware platform like Sci-Fi Unmatched. In China, a lot of company and software community is trying to use OpenEULA, which come from Huawei, and it's another open source distro for RISC-V, and you can run it on several hardware like D1 and Starlight board. Some other Linux distribution can running on that, like Slackware and OpenWRT, BuildRoot, Yocto, Open Embed. So the ecosystem is reaching. If someone is considered about making graphics better and want to run it on some portable device, I think Android is the first choice. So Chinese Academy of Science and T-Hat engineer are work together to make Android running on T-Hat platform, and they have made very good progress. And as maybe you can see some demos online from YouTube, and you can see this demo and can run on Android very smoothly. And Chrome OS is another good choice for laptop. So RIOS in China, which is a non-profit organization supported by RISC Foundation and Tsinghua University, working on this OS porting, and they already make a very good progress. They already made stage 3 imaging running on QEMU. So we are looking for this imaging and see if we can run it on real hardware. So for now, we already have a lot of different distribution running on RISC-V, and we can see some hardware platform is running Linux distribution. So the software ecosystem and hardware ecosystem is reaching, and it's richer. And so we also expect more and more platform can be supported. So we want you to, if you have some hardware platform is Linux enabled, please let us know. We are very glad to help you to make Fedora running on that. So as you may see, this is my RISC-V development board collection. For now, if you compare with 1 or 2 years ago, you may see the RISC-V is developed very quickly. So let me do some introduction of software components for RISC-V PC and server platform. First of all, you may can see OpenSBI is the very first running firmware on RISC-V. So this firmware is support quite well. Normally, you can just use a generic platform with the right DTB. For most of platform, you don't have to. It's no patch required for most of platform. You can just compile it and running on a lot of different platform. And for uboot, and for now, the upstream support is quite well. Most of platform just need some patch for the board level and SoC level. You can run the uboot on that, and we are accelerate the upstreaming process for uboot for different platforms. Grub2 has been most of the patch for Grub2 has been merged, so you can just build a Grub2 and accelerate by execute by the uboot. So for now, the current standard boot flow for Linux distribution is like that. The first of all is boot room, and then the vendors, and then is the vendor firmware. After that is OpenSBI and uboot. In the future, we're gonna support UEFI with ACPI to replace the OpenSBI and uboot. But I don't think replace is the right word. We should say in the most of a situation, UEFI and ACPI is a good choice, but you also can use OpenSBI and uboot. So they are the very standard firmware for booting Linux distro. Then after this firmware, we can boot the standard bootloader called Grub2 to booting Linux distribution. So that's the very standard boot flow for now. And let me introduce some Linux distribution on real RISC-V hardware. As you may see just now, the boot flow is the Windows firmware and a genetic firmware and grub and Linux kernel. So that's the two different two different RISC-V platform bootload. For D1, they have a special boot 0 firmware. Then it's a normal OpenSBI uboot, which you can just flash it into a SD card. Then you can see a little bit different on sci-fi on Vision 5 platform. They have two-stage Windows firmware. Then they will boot OpenSBI and uboot. After that, you can boot grub2 and the Linux distribution. So most of the time, you can see the blue box is almost the same. It's a very standard boot flow, and the firmware will be a little bit different, but uboot OpenSBI will be the same. Will be in the same position. So this is the picture we have made once we boot up the graphic desktop on these two platforms. The left side is D1. The right side is Starlight Vision 5 board. So if we wanted to run standard Linux distribution on RISC-V server or PC, we need more support. This picture is being shown several times. 1 or 2 years ago, the symbol like RISC-V, there's a RISC-V logo there. You can see it's a question mark because we don't know how to do it. But right now we have in RISC-V Foundation, we have a Unix platform spec group. So they are trying to make a specification for Linux for Linux platform. So make this specs after this. If we make this specification, we can have standard software running on standard Unix platform spec server or PC. So after that, once we have an imaging, we can running on a standard hardware. We can have a out of box experience. We don't have to do something like today. We flash different firmware and then need to do some adoption for different distribution. Just everything will be standard. The boring is the best experiments for the standard server. So if we wanted to have the RISC-V PC server, we need to finish several software support like UEFI and ACPI. So you can check the link here, and there's some mini summit in Linux Primer several weeks ago. They have a lot of discussion about that, and people or some engineer already successfully run UEFI and ACPI on RISC-V QNU platform. We are looking forward to work with them and make the UEFI and ACPI running on real hardware like Sci-Fi Starlight, Sci-Fi Vision 5 board, and D1. So thank you very much for having me to do this presentation. We are looking forward to cooperate with more and more engineers, make RISC-V server and PC available as soon as possible. I think in the very near future, like at the end of next year, we may have a server demo, several demo for this event. If I can join this again, I will make make some demo online to show you. And if we don't have a COVID problem, I will go to Japan, Tokyo, can make this presentation again and see everyone face to face. Thank you very much to everyone make this presentation happen. Thank you very much.
Thank you very much, Mr. Wei Fu. So,
Thank you.
Yeah, Wei-san has become a regular speaker at the RISC-V Tokyo. So I look forward to seeing his progress every time. So the status of Fedora on Linux is also great. And the repository is open to the public, and it provides an open environment. The Koji system is also being developed, deploying in the United States and China. So, so you said probably you can do a demo at next Tokyo conference. So yeah, we have to prepare physical event and maybe big space for you, right?
Thank you.
So yeah, so it is supported from yeah. Go ahead.
Sorry. There's some delay because of the connection. So I'm trying to cooperate with some chip vendor and to make this server happen. And the secondary arch for Fedora, RISC-V on Fedora as a secondary arch is our target next year. And I hope that can happen and the server demo will happen. Because once we have a RISC-V server demo server prototype and put into our Fedora Koji system, secondary arch will be made. This we can make it. Yeah.
So one question: will you be focusing your support on Sci-5, Star5, or do you plan to support various hardware platform?
Sorry. If I understand your question correctly, I not just support Starfire's hardware. I also support all the hardware which can run Linux on that, like D1 and the future T-hand platform. But I'm not just working on Fedora, also trying to help other distribution to running on this platforms, because I'm not just a Red Hat engineer, I'm also a RISC-V ambassador from RISC-V Foundation. Yeah.
Yes, thank you very much. And it is supported from Linux PC to server. And I am expecting a RISC-V supercomputer in the near future by you.
Thank you.
How
Thank
about
you.
that?
Yes, and I'm looking
Yeah.
forward to it too. Yeah.
So I'm waiting other question from audience. So please submit Slack if you have question. You can submit Japanese so I can translate as much as possible. So Wei-san, will you attend RISC-V summit in United States next December. Next month.
Unfortunately, I will not attending this event. And I would like to attend that personally, but yeah, because of the COVID problem, I guess we can make it next year. So yeah, I would like to make a presentation on not just online. You saw, yeah.
I see. Yeah.
And for the OpenSBI, uboot, and Linux kernel, I have my own repository online, which can just build and flash into the SD card, can run on several platforms. So I'm looking for more people to can try it, and also I'm trying to upstream some patch, helping some other patch author to upstream the Linux kernel patch like SMPBNT and from T-Hat engineer. So I hope more and more people can support us to make this patch can upstream and just accelerate the RISC-V ecosystem as soon as possible. Yeah.
Yeah, that's great news. Yeah. So yeah, your repository is open to the public, so everybody can see and test. And yeah, so please feedback to Wei-san. Yeah, if you found something. Okay, Wei-san, so thank you so much. Your wonderful presentation.
Thank you for having me.